fuel cells, and specifically proton exchange membrane fuel cells. You know that there's a lot of interest right now in developing alternative energy sources to petroleum, and one of those sources is hydrogen. We can use hydrogen as a fuel. So the idea is to take hydrogen, combine it with oxygen, produce water, and get energy out of that process. The name of the game in fuel cell technology today is to come up with designs that overcome those irreversibilities. And so right now, the standard catalyst that's being used by the industry is platinum catalyst. And that's actually the main reason why fuel cells right now are not commercially viable.
You know, like you said, the metal start becoming not a metal. Like it's not a metal anymore. It starts to lose its hardness or whatever. So would you be able to put something like on the bottom of it for protection, like once it start to fade away?
That's a great idea. Right now, fuel cells are not commercial yet. But it's your generation that's going to be working on these fuel cells in one fashion or another. Stainless steel plate that's used in fuel cells, again, to guide reactant gases through the structure of the cell and onto the catalyst surface. You can see the water is actually beating up on that surface. It's a fairly water-repelling surface, hydrophobic surface. That's not very good for actual fuel cell operation. So ideally what we would prefer is a very hydrophilic surface. So you can see what we do is we take coatings in order to try to make these liquid droplets spread out. You can see how these droplets are now actually moving along these channels rather than staying on the surface. So we're very fortunate in this university. We have a test stand that's very similar to test stands that are used in industry in order to assess the performance fuel cells and the different components that are inserted in fuel cells. And that test stand is next door. It's actually the test stand that Anthony was working on. Actually, we had just bought the test stand when Anthony started to work in my lab. And so Anthony was pretty instrumental in working out the bugs of that test stand. In words, what it basically allows us to do is isolate what the different issues are, what the different problems are that are associated with fuel cell operation.
So the goal here is really to find an optimum voltage that will give you a current and you maximize the power that's being generated in the fuel cell.
Yeah, so when they coming in from space or whatever, they got that chamber where they can take all their stuff out or whatever and still transport in and not lose any oxygen and all that stuff. Could you possibly apply that same method to the fuel cell where there's a chamber so that we can, like the water can come into the chamber, it'll close off up here and let the water fall out and you still won't lose any?
Yeah, I would say that's the main issue, but that's a good observation. That's analogous to exactly what we're trying to do.
At the time I didn't know what type of science I wanted to get to. She wanted to expose me to a lot of different programs, and this one happened to be the one that stuck in my life very much. It really changed my life actually. At first I had no idea what I wanted to do with my life or anything. And this really gave me a goal that I wanted to do. I'm going to continue my education at Withrow, obviously, and then I'm coming straight here to UC. Chemical engineering all the way.